Awesome.
All right. Hey, everyone. Thanks for being on just a few minutes early. We are going to give the rest of the attendees just 2 more minutes, and then we'll get started.
Sounds like a plan. Mhm. That's pretty funny, Joey. Here I am trying to entertain people, and all he's told me to turn it down.
I think he's just concerned that the RCAA is going to come after us for royalties.
Come take my $4. That's all I can say.
Well, I've got
Anyway,
11 o'clock. I think that's as good a time as any to get started with this. So thank you once again, everyone, for joining us for another one of these webinars. I believe this is number 7. And as I look down the list of attendees, I'm definitely seeing some familiar faces. So if you're one of the people that have been through all 7 of these with us, we definitely appreciate it.
shouldn't you get some sort of an award or something,
I,
or some sort
it,
of a
I'm
badge or
I'm trying to think of how we can do that, but
wall of
don't spoil
shame?
anything. So just a couple of
Uh,
quick things. I know some of you who have been here every time are tired of hearing me say this, but we do have some newcomers as well. If this is your first time on GoToWebinar, you should see a little orange arrow in the top right of your screen. Use that arrow to kind of expand this menu. You should have ability to change your audio settings and whatnot. So use that if you're having any trouble. You also see handouts. We have 5 handouts today, so quite a few little bits of homework there for you. One of those handouts is the copy of these slides here. So if you're wanting these slides, go ahead and download those there. And then you'll also see the question box. That's the easiest and best way to get in touch with us if you have questions. We do want this to be as interactive as possible. So if you have any comments or anything, we'll send them through there, and we'll make sure to acknowledge them. So as always, we do appreciate the feedback. Send any comments, topic ideas, and anything our way. This webinar, I say this every time, is for a general audience. A lot of people with a lot of stake, a lot of skin in the game when it comes to crawl spaces. So we may offend some people. I'm just going to go out and say it right now. And also keep in mind, there's a lot of references to code and stuff. We'll try to make that easily digestible for those of you who don't have a lot of experience with code. Without further ado, I'll let you introduce yourself, Mike.
well, I was thinking, we've been doing this a while, and I was thinking maybe I would introduce myself as this guy on the left, and I would introduce you as the guy on the right. And we both have some background with building science and experience with construction, and so on. But that we're both really trying to embrace wearing a mask. And so that's me wearing a mask, but unfortunately Joey's going in a different direction. So I do like that we have the same tilt on our head on that one. Yeah. So anyway, welcome. If this is your first time, thanks for joining us. And we have had a lot of fun doing these webinars, and we really appreciate the feedback. And you can email us or whatever. And our organization, Southface, also we appreciate any support you can give us, because I want to keep doing these if we can. So special thanks to, I know some folks have voluntarily paid money to get the $15 to get the continuing ed credit, and that helps support our organization. And also, we're a member organization, and you can join. It's not that expensive, and it helps keep Joey and I off the bread lines, I guess. Is that a fair statement?
Yeah, we just redid all of our memberships as well. So there's a lot more perks and things. It's a great way to get involved with the sustainability scene in Atlanta. And, you know, we have people from all across the country that have joined our members. So.
Thank you. And then, as always, when I pitch, there's some good resources on the Georgia Energy Code that we just wrapped up, and the field guide in particular is a pretty user-friendly document. But Joey, I love that you added this. This is the link. If you want to view any of the codes, you can view them. You can't search them. You can buy them, obviously, but they have the codes available online for anybody to look at. So if you want to see the code language about crawl spaces, you can just go to that website right there at the bottom. Okay, anything? Boy, if ever there was a good example of why this building science stuff is important, it sure pertains to crawl spaces. So this is where we're looking to really apply the physics of heat, air, and moisture, and it's just such a wonderful topic. I'm definitely excited about it. And the house is a system. This is our go-to mantra. But think about it, everything here that pops up, the envelope, the weather barrier, the conditioning aspect, ventilation, appliances, and how it's sited, all of that, there's a crawl space connection with every single one of those. There's also a crawl space connection with the people that live in the house too. So I think that's really important. So, oh, we're gonna have a poll up front here. So Joey, let's just see who on the line has some experience with crawl spaces, and let's actually see if anybody lives in a crawl space, or not in a crawl space.
No, it is a crawl space.
Okay, let's see what happens. So have you ever lived in a home with a crawl space? And maybe some of you can say, yeah, I did in the past, and some people currently do, and some people currently do and don't necessarily like it. And I think most people probably know what a crawl space is. So can you show our poll to us?
Yeah, so we got a little over 50%. I'm going to go ahead and share the results. I'm hoping that what is a crawl space was Ali playing a joke on us, but we've got a couple. We have some people love it, some people hate it, and I'm wondering, you know, if those that love it have, you know, maybe a conditioned crawl space, and those who hate it maybe do not. So.
Yeah, I like that. That's interesting. Yeah, I would put myself in the purple category there too. I currently do, and I really love it. So, and I'd love to have a philosophical debate about why we like crawl spaces over other types of foundations. Okay, driving on. Let me see if I can make this click forward here. There we go. We're assuming that you, if you're listening, fall into one of these categories. If you're not, please use the chat feature and just tell us who you are if you're not on this list. But this typically covers most of the folks that we have listening in. And as always, Joey has done a wonderful job of putting learning objectives, since that allows us to get you continuing ed. We're going to essentially, you know, try to take a scientific approach to crawl space and see the good and see the bad and see the ugly. I think that, did you like the setup for that? I want to know, I think we should have a poll. We're not going to do it, but I bet a lot of people on this phone call have been in a crawl space that looks something like this, where you have some evidence of drainage issues. You have no plastic on the ground. You see, let's just say, not a very stellar insulation install. lots and lots of problems. And I can certainly say I have been in my share of crawl spaces like that. So we're gonna go dive into that deeper. Um,
Someone chimed in and said that that was actually a picture of their crawl space. So
yeah, exactly. It's just a lovely place to be. So the old way of thinking, I just have so many. I get all excited about this topic because uh, when I started really getting into building science and teaching code and stuff was in the mid 90s. And I was going to tell my story, Joey, about my friend Bill Warren, who is just a brilliant building scientist in Chapel Hill. He and I were doing a lot of training around the Carolinas at the time, and we would talk about crawl spaces and kind of get a debate going in the class, and it was a lot of fun. And I was like, I hope people had a reaction when I put that up about how moisture problems seem quite prevalent in a vented crawl space. But when we were talking about, and we explained the physics, if you've been on to some of the other, we talk about the psychrometric chart and understanding that when you live in a humid climate, we've got some very high dew points. And, we'd go through all this and we'd say, it really doesn't make sense to vent a crawl space. But you would have thought that we were just blaspheming. Like, it was really interesting to see how people reacted to that. Some people were like, yeah, you explained it, I get it. But others were just adamant that that you had to have vents. And I remember this one guy, he was an engineer, and he got so angry, even though of course we let him talk, we had a good discussion. He got so angry he couldn't sit still. He had to walk around in the back of the classroom, and we calmed him down eventually, but it was pretty funny. So I realized that crawl spaces have an emotional connection for people. Maybe that's what it comes out at. And also, Joey, this is really fascinating. I was doing some research. There's actually 2 horror movies that are called Crawlspace. One was a German one, and it has a pretty famous actor, Klaus Kinski, in it. And this other one was made in Australia. My favorite is the tagline, in this space, everyone can hear you scream. So, which is me whenever I go in a crawl space, right? So let's pitch it right now. Let's put it right up front. If you do a proper closed condition crawl space, there are so many pros to it. There are so many advantages to this. It really, really works. It basically, makes you have to deal with moisture issues, which you might ignore otherwise, and you shouldn't, even on a vented or unvented crawl space. It makes sure your equipment is pretty efficient. If you have combustion, you're going to have a 90 plus efficient furnace, and you're definitely going to be paying attention to the plastic vapor retarder. So what are the advantages? You're able to maintain the interior relative humidity levels, and you're going to have a nice crawl space. Your risk of growing mold is greatly reduced compared to a vented crawl space. I can definitely attest to this. The floor above is so much more comfortable in the wintertime. That was a huge benefit. I think my wife finally believed I knew what I was talking about when we did this crawl space retrofit, and it was so much more comfortable in the house on our floor. There's generally going to be energy savings for several reasons. One is, like I talked about the floor, there's no real temperature difference now across the floor in the wintertime. You also actually kind of get a little bit of sort of ground coupled free cooling when your walls are are not vented and insulated, and your floor over your crawl space is sort of ground coupled. So there's a little bit of benefit there. Your structure, your finished flooring above that, and is much more stable and much happier, and you don't go through that cycle of in the summertime it's really humid and the wood gets essentially very saturated and swells up, and in the winter it's over dried and cracks and shrinks and then repeats the cycle, and your floorboards buckle and all that. So your floor is much happier. The pest risk is reduced because termites in particular, they like wet wood. So we're paying attention to keeping our crawl space dry in a very deliberate manner. I will say we cut down on entryway for critters, particularly the 4-legged ones that look like squirrels with skinny tails. We have not had a single, mouse or other problem since we closed up our crawl space. So that was a huge impact to kind of take that away. Ductwork, of course, is inside the conditioned envelope. That's another huge energy benefit as well as health. Your pipes won't freeze, and I think that's a big one, particularly in sort of the southeast. And I guess if you want, you could sort of say I have a conditioned area I can store things in. I store some non-off-gassing building materials in there that I don't have another place for. So I think that's a nice benefit. There's some downsides. There's a cost, absolutely. It is not a cheap effort, and it is a big effort to retrofit a crawl space. You have to potentially upgrade equipment. You got to address the moisture issues, but you want to do that anyway. And there's money to set it all up. I say there's money to operate as a conditioned crawl space. I really feel like you're going to get net energy savings for the effort, but you're going to run a dehumidifier maybe. It costs money to take out the old insulation and install new, and always want to push for a monitoring system. Your radon levels could increase. If you had a vented crawl space, some of that radon theoretically can get vented out. Your biggest risk, I would say, is probably from non-believers, folks that will come in and tell you, oh, you got to have these vents that are sealed up, and just do something stupid. They don't understand what's going on, and you cannot store. You do not want to store nasty stuff in your house because the crawl space is now in your house. And then finally, there are some places where maybe this is not the best strategy, and I would say if you're in a floodplain, they do actually make smart vents that are designed to be normally closed, but then open during a flood and allow the water out and then reclose. So that is an option. But if you also can't get in your crawl space, maybe that's a challenge too. And then Joey, this is interesting. It depends on who's doing the retrofit of kind of how things get done. For example, if you have a waterproofing contractor, they get the moisture details. They tend to do a pretty good job, but they don't necessarily do the energy details. If you have an insulation contractor, they'll really air seal and insulate that wall right there. But then the pest control people come along, and by the way, they think they own the crawl space, but they can't see it. So, they're very upset by not having a view strip. So there's a lot of, it's an interesting place that a lot of people seem to think they own it. So I always found that fascinating too. So just lots of fun nuances to crawl spaces. Joey, why don't you take over for a minute?
Yep, same old thing that we've been talking about here. Heat is a form of energy. It's always going to move from hot and cold. And then we have these three methods. And of course, we've been talking about this in the context of an attic space, but what is a crawl space if not just an upside down attic? Slightly different. Obviously, you don't have the convection that you do here. And we'll talk about why that's potentially an issue for a vented crawl space here in just a minute. But it's fairly similar.
Good stuff.
And yeah, and we're going to particularly focus on the air movement again because if the ideal, according to building codes and according to the old style of thinking, is to have a vented crawl space, you have to really understand how air movement works and maybe how it doesn't work in a vented crawl space. So remember, there's three driving forces of air movement: wind, stack effect, mechanical effect. And hopefully the gears are turning in your head already trying to think about how each of these impacts a vented crawl space. Because remember, we need a pathway and a pressure difference. So in this case here, sure, I guess you could say we have a pathway, but is that pathway enough space for the volume of air to move through this crawl space? This is a kind of an extreme example. It looks like probably, how many courses of block do we have there? That's probably 10 feet or so. So that's a tremendous amount of volume. Can that vent really, move all that air? I'm guessing probably not. And then is there any pressure difference? We have to have a pressure difference. We have to have some sort of driving force. In this case, in most cases, I wouldn't say there's any mechanical. I know that they do make mechanical vents for crawl spaces. Again, think about the occupant interaction with that. Think about, do we turn it on? Is it controlled by a humidistat and all this? Not usually in most crawl spaces. Stack effect, maybe if you have a really large crawl space like this one, you might have
Not
a
much.
little
Yeah.
bit of stack effect. But generally speaking, 4-foot high crawl space, very little stack effect. And then wind, we're going to get a little bit of the wind effect. We're going to get a little bit there, but I would say not a whole lot. So not a whole lot of pressure driving any sort of airflow in this vented crawl space. Anything else there, Mike?
No, no, keep going. You're doing great.
All right. But if the crawl space vents don't leak enough air, luckily we have all these beautiful air movement paths that we see right here. A lot of opportunity for unwanted infiltration to go into and out of the crawl space, which I guess is a benefit.
Uh,
Maybe not so much. And you see
yeah.
here, this is kind of a new construction, even, and and no details there, no caulking. We do have the capillary break there. That's really designed to prevent moisture from going to the block, from the block to the wood, but it does also kind of pull double duty in that that little squishiness adds a little bit of a air barrier. But most of the other opportunities for air to move through are still going to happen. And
Sounds
then
good.
all that air that's moving into the crawl space is
Yep.
now going to move into the home. And Mike, I think hit the nail on the head. A lot of people think they own the crawl space, whether it be electricians, whether it be plumbers. They all drill these holes. They all make these huge access points, and no one really comes to clean these up. So we have this air moving into the crawl space and then into the living space. And then the subfloor, is that really ever going to be able to provide an adequate air barrier? I know the old style of doing a subfloor with maybe one bis or tongue and groove or lap like this is probably passe at this point. But even a sheet of OSB or decking is going to have 24,
Leapholes. Yep.
yeah, all the holes. It's going to have at least 24 linear feet of leakage around the edge. And again, no one's really coming back to seal those up. So if we think
Well,
about our
just
air
yeah,
barrier,
no, I was going to say, just think about how hard it is to make a flat ceiling in an attic, airtight and then properly insulated, and then now try to do it upside down from underneath and trying to get insulation to stay as well as air. It's just really challenging to make the floor be a good, effective part of the thermal envelope. So,
yeah.
yeah.
And
Okay.
remember,
So that's kind of what that said.
exactly. And I always point to the IEC's definition. It's not just the materials, the plywood, not a whole lot of leakage is going to happen through a sheet of plywood, except around the joints and how it's connected to every other piece of plywood. And then keep in mind that in that ventilated home, the air barrier is the subfloor. And is that really, really what we want? And the answer for me is no.
Yeah, and oh, I think my text didn't show up there. I guess it didn't
Oh,
make it in
here
this
it
version.
is.
So, oh, there it is. Okay, good. It pops up. I was going to say, conduction, we're dealing with the energy flow across the foundation, and we can choose to insulate the walls, or we can choose to insulate the floor. And I just thought I'd share it. Like if I take the dimensions of my own crawl space, um, my house is a 30 by 50 footprint. So that's 1,500 square feet of R19 underfloor insulation. But if I was to do the walls and it was a 30 plus 50, that's 80 feet, double that, that's 160 feet around the perimeter. Let's call it a 4-foot high crawl space. That's only 640 square feet. And by code in my climate zone, I only need a continuous R5. We'll talk about what R value you need, but certainly, a fraction of a fraction of the area that has to be insulated. And ultimately, if this gets my ductwork to be inside, then it's worth it. That's the big win there from an energy standpoint. So we'll talk more. Also, as we keep saying, this picture I think was one from a project my wife ran into where they encountered a house that had, this kind of crawl space, and you just look at it and you go, well, all of the floor framing and plumbing and wiring and ductwork that's in the way. And gee, how permanent did that insulation stay up there? Was that gravity? Was that a contractor? I don't know. But then you look at the walls and you go, gee, that would be really easy to insulate those walls instead of trying to make the floor airtight and insulated. So it's just, you know, step back and look at the picture here and see we could do a better job on the wall on that one. And then of course the challenge with floor insulation is very hard to get to do right. It's particularly hard with fiberglass bats. And we've just seen so many bad bat pictures, and I'm sure people listening have too. So
Yeah.
go
And
ahead.
if your insulation does have a big gap like this, 3 or 4 inches, we always say that insulation needs to be in contact with the air barrier, and there's a reason for that. A product like this is a medical device designed for people with diabetes. But if you were to put this under your covers and go to sleep at night when it's a little bit chilly outside, your feet are not going to be very warm because that you want the insulation to be touching. So keep that in mind when you see insulation that's kind of fallen down a little bit like this.
Yeah, and I've seen people run chicken wire underneath the floor joists and all kinds of it. It just doesn't work. It's got to be touching the air barrier. So again, I think the importance of continuous insulation and continuous air barrier, it's just a challenge to do that well in a floor situation. So I'm going to advance. So we talked about air movement. We talked about heat. Now we're going to talk about moisture. And a crawl space is so exciting because it's got the potential to represent every single one of these. And the most obvious one is bulk moisture, which is of course rain and drainage. And you can see this disconnected or poorly aligned downspout here. The water, poor drainage gets into the foundation. We know there's going to be problems. We know that the block in particular or concrete can wick water very easily. The vapor barrier that we put on the ground, the plastic that we put on the ground, is to stop water vapor from diffusing up through the dirt into the crawl space. And the other way moisture gets in is if we vent our crawl space, we're just carrying whatever is in the outdoor moisture content is now going into the crawl space. So kind of exciting from that standpoint. I would guess that this picture is a bulk moisture issue. I don't know. That's an indoor swimming pool. I'm not sure what that is. Yeah. So just a real quick, here's a tie into our friends at Advanced Energy that did this excellent research, and it was in the early 2000s. And I love this graph because it shows, it was so definitive. It just shows that if you have a vented crawl space, they actually looked at 12 houses and they built them in different configurations. But you can see the vented crawl space just dances with the outside air relative humidity. It just follows it for the entire summer. And you can see that we talked about how 70% is the sort of the mold switch. And you can see that almost 80% of the summertime, the relative humidity was above 70% in the vented crawl space. Whereas the closed up crawl space stayed right around 55% RH and did just fine. So lots and lots of good stuff there. Please go to their website and they have some great little videos. The other thing is that this slide or this graph is actually plotted for the entire year. And what happens is if you look at this during the winter months, the vented crawl space goes way down and it ends up being over dried. And so you get this way too dry effect in the cold winter, and then you get this way too humid effect in the summer. Whereas the closed crawl space is just chugging along. So, a much happier condition. Okay, and again, we just want to emphasize the code allows you to define the thermal envelope, sort of the old school approach, but you can also include the foundation walls as part of that. It says indirectly, there are ways to do that, but mostly we're going to advocate for a directly conditioned crawl space. In terms of the code, let me just say that there really, somebody did some great research trying to find out where did crawl space venting actually come from. And it traces back to the 30s, and they had some, I want to say it was in New Jersey, they had some wet crawl spaces, and they tried several things, one of them being essentially effectively a ground vapor barrier. and one of them being vents and some other stuff. And they said, we really think it was the vapor barrier that mattered, but somehow um, building advisory steps that weren't even called codes then really picked up on venting. And so for a long time, the venting was the answer, even though there was absolutely no science behind it. And anyway, so there's a lot of stuff that's still in the code just because it was always in the way we always built. And so here's the basic what the code says. There, you can go to the website and see the exact language, but it says essentially, if you're not going to put a plastic ground cover, you're going to be what I like to call a highly vented crawl space, where you have 1 square foot of net free area, which means you have to account for the grill of the crawl space, vent in the screen or whatever. So you have 1 square foot of net free area for every 150 square feet of floor area. So that's a lot of vents if you actually don't put the plastic. And then they said, okay, if you use the plastic, then we think we maybe still want you to vent. I don't know, but okay, we're going to say 1 square foot for every 1,500 square feet. So most crawl spaces built in the more modern area said, oh, I can save on crawl space vents if I just go this approach. What's fascinating, Joey, is that the two ends of the spectrum perform really well. So if you have a house on piers and it's really wide open venting underneath, wide open, like my dog can run underneath it. Usually that floor has a hard air barrier underneath. Those houses actually do pretty well. They perform well. They don't have mold issues under there because it's so highly vented. And the other extreme is the closed condition crawl space, where we're not venting at all. And of course, the benefits of that, all the stuff is inside the conditioned space. But the problems tend to be where we go in between. And
Right.
so that's the interesting part.
Yeah, when you try to do a kind of a half measure and trap that moisture in there, thinking of weatherization, I'm immediately thinking of mobile homes that have kind of skirting. That's
Or
usually,
belly board, yeah. Yep.
yeah. So that's an issue, and of course this is highly dependent on where you live as well. You might not want to use a vapor barrier in areas where you have a lot of moisture coming in, through the air, because that might condense on the vapor barrier. So that's an issue that has been talked about a lot in weatherization. It's been a really contested topic. So you always want to keep in mind, where you live. And unfortunately, the building code and the energy code, as far as crawl spaces are concerned, don't really make that distinction.
Yeah, and I just think this is one where learning the building science physics can help you make good decisions. I'm going to be an advocate of plastic on the ground. It keeps ground water vapor from getting up. We'll see that in a second too. Also, I see a lot of houses that sort of supposedly build this, but they don't really follow the code. And even then, I think the code is flawed. But how many houses have you seen that have crawl space vents that look like this, where the water can just flow right in,
Right.
and poor site drainage that's just saturating the brick here. And this is one that I've seen on a number of houses too, where they put the outdoor water spigot really near, or in this case, right over the crawl space. I wonder if there's any way that could ever freeze in the wintertime. It just seems like we just don't connect the dots with vented crawl spaces. So if you live in a humid climate, I just don't think it's a good thing. I'll stick my neck out on that one. So the code in more recent years, and again, much thanks to the research that was done by Advanced Energy, and that research really, all it did was just prove psychrometrics. It was something that anybody that actually understood psychrometrics could have predicted the outcome, but it proved it. And then after that, people were like, oh yeah, I always knew that, and you're like, huh, okay. But we spent the last, let's say, 18 years trying to help change the industry. And I would say we've made a lot of progress on this. I think people today tend to at least get this more. I still know that there are people, though, that are still building vented crawl spaces. I don't like it, but they can do it. So what the code says is if you want to do an unvented crawl space, you have to have a really good class 1 vapor retarder. And that's a fancy word by saying at least 6 mil poly coverage, 100%. The seams have to overlap at least 6 inches and be sealed. It has to run up the foundation wall and the piers by at least 6 inches. A lot of people wrap it all the way up the foundation wall, or almost all the way up, which is a good thing. So, you know, you got to do the plastic, and then you got to follow one of our, oh, sorry, I jumped the gun here. Joey, what do you want to say about this? We're talking from a liquid moisture standpoint. I think we've covered this, but there's bulk
Yeah.
moisture issues, and that's drainage issues, and there's also wicking. And it's a great picture.
Yeah, I think this is probably a similar situation that we saw, that disconnected downspout. It just happens to be in a perfect little area there. So definitely
yeah.
telling me that that's bulk moisture and probably not capillary from the ground.
And while I'm thinking about it too, another source of bulk moisture is actually plumbing. I've been in a number of crawl spaces that had plumbing leaks. So, and including a small one, even in my own, that
Uh-oh.
we found it when we were remediating it, and I soldered it and fixed it. So it was not a big deal, but it's something to also pay attention to. In terms of vapor barrier, this is what I wanted to say is the plastic is kind of, think of it as a liner. And I threw this picture in. We were on the right. We were doing some I don't know, assessments of this building, and it had plastic, but it was only, you know, it wasn't sealed. It was only on, you know, 90% of the floor. But in the course of crawling around, one of my colleagues, I guess, kicked it or whatever, and you can see how the plastic was actually doing its job, was keeping the ground moisture from getting up into the crawl space. And I've definitely had people say, well, my crawl space looks dry down there. And it's like, well, there's still a lot of water vapor that is coming up out of the ground because the plastic is not there. The other funny story on this is, Joey, this was something, you know, a lot of people had crawl spaces, you know, in the 90s, and we're telling them, yes, put plastic down, put 100% coverage. And then a couple months later, you know, the phone would ring and somebody would say, I put that plastic down and there's all this water underneath it. And we had to explain that that was a good thing. So, but our solution to that was, now we just say, well, put black plastic down and then you can't see the water. So yeah, solve that problem. Anyway, so I think that's important to understand how vapor barriers work. So once you've got the good plastic coverage, then the code says, okay, you got to satisfy one of these options that is going to effectively condition it. And the first option is one where you're exhausting air out of the crawl space. And I think the logic here, this is not one I have ever done. It's probably not the most appropriate strategy for where we live. I'm not saying it maybe couldn't work in some parts of the country, but in humidity land, I would stay away from this. But the idea is that you're always going to exhaust air out of your crawl space. And probably what will happen is you'll get some conditioned air pulled from above down into, in essence, indirectly condition the crawl space. You know, you could make an argument that maybe if you did a radon vent system, you're exhausting from the crawl space as well. You know, maybe you could make the case for that. That's really, to me, doing a different purpose. But the amount of air that you would be required to pull out was 1 CFM for every 50 square feet of crawl space, or 2 for every 100. And you know, I have a 1,500 square foot crawl space, so that would be 30 CFM. So it's not a lot of exhaust air that we're talking about. I don't know. Any thoughts on that, Joey, on this strategy?
Yeah, I think that someone in the chat is asking about one that might be humidistat controlled, but as far as the code is concerned, they really require continuous. So that thing would have to be running, you know, all the time. And again, I don't think that's probably the best solution.
I agree. And there are, you did mention this earlier, if you have a vented crawl space, there are retrofit fans that you can put in that have a humidistat. And what they're saying is they usually, I even had, I'll show you a picture later, that they would run one way and check the crawl space humidity, and then run the opposite way and check the outdoor humidity. And if it was drier outside than inside, and at least that's an intelligent strategy, then it would run to dry out the crawl space. But the reality is, you're still, you can still over dry it in the winter. And I just don't think that's the best strategy. So the other approach you could do is to condition your crawl space. And so it's the same amount of air, 1 CFM for every 50 square feet or 2 for 100 square feet. And this is probably one that is done on I would say this is more widely used. I have mixed feelings about it. I think it's got some nice things about it. It's pretty cheap to sort of add this feature or retrofit this feature. You're basically just going to supply a little bit of air. We'll talk more about too about do I need to run my insulation all the way up or leave a 3-inch gap kind of thing. And the HVAC system can condition the crawl space. Yes, then you have issues of I'm putting supply air here. Do I need a return path? And the code has some language about that, about a transfer path. But my biggest issue with this, I've seen this work well, but I have also seen this fail. My biggest issue with this is it's being the operation of this mechanical system is being controlled by a device that is looking at temperature, and it's not looking at moisture. And where is the device located, Joey?
Upstairs.
It's not in the crawl space. So you got a device looking at the wrong thing, temperature instead of moisture, and it's not even located in the space we're talking about conditioning. So that's my biggest issue. If that system is oversized, you're more likely to have a problem with this. If the system is going to run a lot because it's undersized or right-sized, that's going to work to your favor. So this is an option. It is allowed by code. I think there are pros and cons to it. I will say I'm much more of a fan of directly conditioning this crawl space with a dehumidifier. And I would argue, and I have written interpretations for this that say, if you put a dehumidifier and it supplies 2 CFM per 100 square feet, and it's recirculating the air in the crawl space, you have conditioned the crawl space. And I think that's valid and to me better. You're going to see in the latest version of the 18 code, they finally actually addressed crawl space dehumidification, which I think is good. I don't like their result. But anyway, I just want to make sure everybody understands this option. And so maybe what you do is you do this, and you also put a small dehumidifier in there as a safety, because maybe in the swing seasons when you don't need any heating or cooling, but you still need drying, you want that dehumidifier.
Yeah,
Oh, go ahead.
I think you touched on this a while back, but you know, this type of setup is nice because the ducts in the air conditioner in the conditioned space, of course, when you're talking about code, that's a huge benefit because you wouldn't have to do the duct testing in this case.
Yeah, and it's just from an energy performance standpoint, of course, get the ducts inside. And I guess we'll be talking about more about that in next week's webinar. Is that right?
I think that one's in 2 weeks.
Oh, sorry. So anyway, there's your small supply. There is a third option that the code lists, which says, why don't we just use our crawl space as a giant return plenum? And let me just say, I think Joey and I have very strong feelings about this particular option. So don't ever, 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 ever use a building cavity as a duct. Okay, now that we've said that, we'll say don't even think about doing this. But why that's in the code still, I have no idea. The new thing that showed up in the IRC is now trying to address dehumidification, which is great. I love that they're saying that's a good plan. What I don't like is I feel like this is way overkill. And they've said you need a 70 pint per day moisture removal for every 1,000 square feet of crawl space. I think that is put in by somebody that wants to sell a lot of dehumidifiers. But it also means that a builder that was going to do this approach is now not going to spend the thousands of dollars to go this route because it's too expensive. And so this to me is the best strategy, is a dedicated dehumidifier. I think that one's way too big. When I think of pints per day, Joey, what do you usually think of?
It's about the size of a pony keg, I think.
So yeah, everything is in terms of beer for us, right? But anyway, yeah, so these little dehumidifiers that you see, they're probably not going to handle that level of moisture removal. So maybe your strategy would be to put one of these in, make sure the condensate drains to we'll talk about that in a second, drains away. And, but you're mainly going to satisfy code by putting supply air into it. The other option is to get the real super good crawl space dehumidifiers, which I'm a huge advocate of, and they're great. I just think that the code spec is way, it's using a sledgehammer when you don't need it. So that's my opinion on that. And so to wrap up the code, there's also sections. This is all from section 408 of the IRC. There's details about your crawl space access door that needs to be air sealed and insulated. It's part of a conditioned space. You do not want to have any. We always say don't leave, a termite salad bar inside your crawl space. So you really want to get out any scrap, debris, wood or whatever. Just don't make it friendly for the termites. And your grade, there's details about the grade, both from the inside and the outside, and of course, flood issues. So I think that would, flood issue, I just had to put another good picture. I like these scary crawl space photos. These are fun.
I tried not to use that many because I didn't want us to seem biased in any way, but
I want to go on record as being incredibly biased. Okay, I just want to say that. I'm very biased. So for vented crawl spaces, we're going to redraw the building envelope. We're going to think differently, and we're going to install insulation somehow on the foundation wall. The best place for foundation wall insulation is on the outside, but that presents a lot of challenges to protect that insulation. So usually we're going to do it from the inside. And in terms, I would say one of the really more viable go-to options is foam board. And there's really three types of foam board. There's expanded polystyrene, that's the white bead board type stuff. If you're going to go that route, I know there, you can get a white bead board that has a heavy borate in it, and that's a good bug deterrent. There are the extruded polystyrenes, that's the styrofoam products, the pink and the blue and the green and the whatever color they are. And there's also polyisocyanurate, and that's usually got a foil face on it. And that one generally makes code officials a little happier just because you can really, I think you can make a case for all of these is not a livable space, but if anyone's ever worried about fire issues or something, then to use this foam board. But I think those are all good. I've seen people spray open cell. Mostly what we see is people spray closed cell, and I would say that's a more appropriate approach. It's a lower vapor retarder finished result. It's a little more durable for sure. And we're going to talk about there's no view strip here. I even know a person that was doing a heavy borate cellulose sprayed against the foundation wall. I don't see that very often either. And insulating the band is really critical. You want to air seal and insulate the band. This is a really nice job. Whoever did this, they foamed it and did an excellent job. Here's a not so good job. Hopefully they air seal it as well, but they put bats in it. And there's also some kind of pillow options. You can fill up bags with loose fill and put those in, which I think is kind of cool. And of course, air sealing, very, very critical. And, spray foam, sounds ideal. I mean, it is perfect. It's going to air seal, it's going to insulate, it's going to make this super tight, and it does. But if you're in a termite risk state, then that is probably not going to make people happy. So we'll talk more about that. How much R value? Joey, you want to hit this real quick?
Yeah, it's interesting that we've mostly been talking about the IRC, and we think that the crawl space obviously has huge impacts on the energy use of the home. And it's funny that all the venting and everything is part of the IRC, and then we get to the insulation and it's in the IECC. So we switched books here, indicated on top right here. But again, depending on your climate zone, you might these are the insulation requirements. And when you're looking at a code, the first number is generally continuous insulation. So if you're going to use continuous insulation like a foam board, you need to have at least an R5 in climate zone 3, or R10 in climate zone 4, except for the marine, and so on and so forth. And that, of course, is if your state didn't amend any of these charts, which of course is an issue sometimes in some states. That second number there, that's going to be if you have like a framed wall. So in this case here, we have a fiberglass framed wall that would need at least an R13 in climate zone 3, R19.
Yeah, if I was in climate zone 2, I'd still try to get at least something on the wall, but
Yeah.
you're not required. You can do an unvented crawl space and not have to insulate the walls in climate zone 2. But I would say something because block walls are very, very conductive. So it's more of a winter effect that we're talking about. But yeah, that was great. Thank you. Let's see. Other detail, which I really don't agree with, it depends on where you are, but if you read the code, it kind of wants the insulation to extend down to grade and then basically another 2 feet. This is silly in my climate zone. This is just a waste of time and not necessary. And I would even probably make the case for climate zone 4. As you get colder, there is more an effect, and I get that, but I think this should be climate zone dependent. So, Georgia actually amended and took that part out. That is really not going to do much benefit for you. Driving on, a couple other issues we want to make sure we talk about is if you are in a pest control in a pest heavy state, and it's funny, the termites are very bad in Mississippi, Louisiana, Alabama, Georgia, South Carolina, but they don't cross the line as heavily into North Carolina. So it's really amazing how they know the geographic border like that. But there is actually a map in the code that shows this. But many states as a concern about pests require a view strip, and it's typically 3 or 4 inches, and it's right below the floor joists. And so that's great. I get why we're doing that. But from an energy standpoint, if I have an infrared camera on that, I'm going to see, where the heat's going to be really flowing where there is no insulation. So what we recommend is that you put a plug of insulation in there and you put a piece of tape across that, and it's hinged because of the tape. And then you can fold it down to inspect and you can push it back up. So that way everybody kind of gets what they want. You do not have to do this, to my knowledge, but you should. In my opinion, if you really want to be effective at this. The other issue is the band. And so spraying foam in the band is also not making the pest control folks very happy. So it's probably better to air seal it with caulk and then use a removable insulation product. I try to appreciate what the pest control people have to do, and hopefully they appreciate what we're trying to accomplish. So as long as we all kind of, play nice, I think everybody can get what they want.
Yeah. Well, they would probably tell us that, a house that's infested with termites is probably not going to be very energy efficient. So uh,
Yes.
I'll speak up for the pest control industry.
Yeah, good. No, and I want us to give everybody what they need. So I'm absolutely an advocate. Joey, radon is certainly an issue. And if you have a vented crawl space and then you turn it into an unvented crawl space, such as my own house, I tested radon before and I tested radon after, and it did increase slightly. It was at about 2.3, and I think it went to 2.8. And it's always been my plan to test it about every 3 years. I'm a little behind at the moment, I gotta confess. But anyway, if you have a foundation on your house and you do a radon test in your house and you have a problem, the good news is a crawl space is probably the easiest foundation to retrofit. So there's some real benefits to it in that regard. And I definitely think we would want to appreciate that. Generally, with crawl spaces, you put a T in a perforated pipe that runs under the plastic, and that's going to just allow the radon a path of easy resistance to flow up and out. And then this vent pipe can go up through a wet wall, and usually it needs to go above the roof, or sometimes it runs outside the house on a retrofit. And if you have to, you can put a depressurization fan in line. But usually, and of course, label the pipe. But usually, retrofitting for radon, it actually ties well into what you're doing with the plastic and sealing up and everything. So, what are your thoughts, Joey? Anything on that?
Yeah, just coming, like you said, I'm coming from, a colder climate and where we have this in basements a lot. And of course, you have to drill through a slab and
Yeah.
put in something like this. So yeah, it is a lot easier to do. And again, the conditioning and crawl space doesn't necessarily, create more radon. It just kind of slightly concentrates it. And again, if we think about the airflow in a quote unquote vented crawl space, a lot of times they might have problems with radon as well. They just don't really think about it.
Yep, got it. Okay, driving on. Kind of wrap us up here. Combustion safety. You got to use the right kind of combustion equipment. You could have an 80% furnace or a 60% furnace in a vented crawl space. You can have a, atmospheric vented water heater in a crawl space. If the crawl space is vented, you're getting your combustion air from outside. When the crawl space is closed up and conditioned, you may not do this. So you must upgrade the equipment. You can go to a condensing furnace, and you see there's two pipes here. There's a PVC pipe bringing combustion air into the sealed chamber. Very efficient combustion. Exhaust products are pushed out the second PVC pipe. Or you can do a heat pump, and then for water heating, you can do any kind of, I say tankless, I really should say gas, direct vent, or sealed combustion, because that could be a tank or a tankless. It just has to have technology similar to this. You can use a standard electric water heater. The best water heater really in that scenario is a heat pump water heater, because you get free dehumidification. And that's a really nice thing in a crawl space. So a heat pump water heater in a closed crawl space is kind of a dream. Let's keep going. And oh, I'm sorry, I went too far there. Anyway, storage, I just wanted to mention, you don't want to put stuff you shouldn't put in there, like paints and solvents. And it is fine to store your hoarding of toilet paper, I guess, but don't put bad off-gassing stuff in there. And then signage, something to indicate that we want to protect the plastic. And I like something on the door that really says, hey, this is a closed crawl space. Don't do stupid things to this. Don't mess up the system. All right, I'm trying to get to the end here. Okay, summary, and then I'm going to share some stories of my own. So big picture, what are you trying to do? You want to seal the ground really well with plastic. And then you want to insulate the walls to at least minimum code. If you are building a new home, this was one of the first ones we did, what I would say we've learned is to put plastic on the wall and then come in a few feet and do that at this or early in construction before you frame the floor. If you do the plastic at this point, it's going to save you a lot of hassle down the road of trying to do it afterwards. And then why do you not cover the entire floor with plastic? Because if you do, it won't survive construction. It'll get chewed up. But if you just do a few feet in and skirt all the way around the perimeter, that's a good strategy. Why not go ahead and insulate the walls at this point? It's really easy, and you don't have to crawl. You can bang this wall insulation job out really fast if you do it at this stage. Then you come in and do your floor framing, and come in later at the end, and you can finish the plastic. So I think it just makes sense to stream it like that. Obviously, we're not going to use vents. We have to pay attention to access doors and do them correctly. We want to follow the code and either condition it or condition it with a dehumidifier. Those are my two recommendations. Probably the dehumidifier either way is the recommendation. And important details with don't have stupid drainage. Don't have, I had to retrofit a French drain on my own house. I had to retrofit the furnaces to update them to 90+%. All of this had to be done before I could even think about getting rid of the vents. And then make sure people understand what you're doing. I think today we've done a better job. There's a lot better awareness of this. I like the idea that we're paying attention to moisture. We may need a sump pump, if that's the case, follow the rules. And of course, test for radon. So here's my last thing, Joey. I thought I'd share pictures of my own crawl space. This is what this is what my tub drain hole looked like, and I sealed it. And you can't see the ugly falling down insulation, but it was there. This was my pan return. We'll talk about why we don't like those, but I'm wiggling my fingers in the crawl space, and that's a return duct, so it's sucking in crawl space air. So I sealed that with mastic. And then the first thing we did was to really try to get plastic down on the ground. So try to get the plastic down, and then eventually, then we sealed it to the piers and to the walls better. But just the main thing was to get it on the dirt where it's doing the good. Then we started, and then I removed the old insulation, which was like the happiest day of my life. Getting all the old insulation out of there was a beautiful thing. It was just disgusting. And then we started insulating the walls. I chose to use a foil-faced polyiso board. I think I used mostly an inch, which is a little more R value than the minimum code, but not much. And you can see where there was tape at the hinged places where you can inspect. There was foamed up, crawl space vents. The old vents were sealed up, and that's kind of what it looked like when we got done. The access doors, I do not want to understate what the work was involved in the access. It turns out my crawl space had 3 access doors, and then we had to build a wall because part of the crawl space extended out to the front porch, and now the front porch is a vented crawl space, and the house, of course, is conditioned. Whoops.
Sorry
So
about that.
no, it's okay. The conditioned crawl space, we had to build a wall, so that actually meant a 4th door to go from the conditioned crawl space into the porch vented crawl space. So all I'm saying is it took about 5 hours per door to air seal it, insulate it, get it to really snug and fit, and just don't underestimate the effort there. And you really want to get this door to be done right. And mine is it works out pretty well. And I guess it snowed that time. Also, that's a picture of a moisture alarm and moisture monitor, which I put in, and I recommend that. And then that was the original dehumidifier I had, and it was a 45 pint per day, and it drained to the air conditioner condensate pump. And also I had some of these little fans that I would my crawl space, some crawl spaces you can really get and see good air circulation. Mine really doesn't have that. So I just wanted to stir the air a little better. So I scattered this fan around, and I put it on a time clock to run with the dehumidifier. It would run maybe 10 hours a day or something, and everything was working fine. It would keep up with the load. It would do great, and I had no complaints. These dehumidifiers are nowhere near as efficient as the bigger dehumidifiers, I will say that, but it did fine in terms of moisture. However, it got recalled because it would burst into flames. So I decided I should probably, sorry for all that, I should probably do something about that. So I took it out and I put in a real ducted dehumidifier, and that's it from a distance. What happens is the duct, here's another picture. The air is pulled in from this side. It has a nice 2-inch pleated filter. It conditions it, and then it pushes it around, and then it actually turns 90 degrees, and the duct runs all the way down. And it basically conditions almost the opposite side of the crawl space is where the supply air goes out, and the return air is pulling it from here. So that's good circulation. And I also put this on a time clock because I try to run it during the daytime when I'm most likely my solar panels are doing something. So I thought I'd show the condensate drain line with a P-trap and a clean out, and how it slopes and drains to the condensate pump. And I even put a liquid water alarm right here. The sensor's right here, and so in case something goes wrong with this pump, it'll send me a signal, and there's the other moisture alarm. So I just thought I'd share some of the details of what goes into a retrofit. And I noticed that we finished right on time, Joey. Great job on your part for keeping me in check. And my last comment, I just have to share, and then let's open it up and see if we have any comments or questions, is the idea that I've talked to enough people that people recommend, if you're going to use a thicker woven mesh reinforced plastic, which I really like, in your crawl space floor, apparently the white plastic can sometimes off-gas a cat urine smell, and that is not friendly to the homeowners. And I remember I was talking about this crawl spaces, and I had that question come up, and I'm like, huh. And so many contractors said, yep, I've had that happen to me. We had to replace it. So I'm just going to say it's probably the same price. You might just want to err on the safe side. I know some crawl spaces haven't had this problem. I don't know what causes it, but that's my only comment. So anything you want to add on that, Joey?
No, I've never experienced that particular product, but it doesn't sound very pleasant. So I'm glad that I haven't.
Agreed.
Yeah, if you're new to the webinar, we do like to kind of generally wrap up around 12, but we do stay on for at least 15 or so minutes to kind of answer some questions. as we predicted, we got quite a few questions, and I think some of them might have to be taken offline because I can't even. I need about 10 minutes just to read the prompt here, but we'll
Any
try to
death
we'll try
threats?
to yeah, we'll try to get to some of these. And then again, if you're gonna jump off now, we do invite you back next week, same time. We're gonna be talking about. Oh, you were right. We're gonna be doing ducted mechanicals next week. I'm sorry for that. And then we're gonna do roof lines the week after that. So 2 more weeks. We are also, thinking about what to do going forward. It seems like a lot of us are gonna still be inside. So if you want us to keep going with the webinars, give us some feedback. If you think, we're doing too many, not enough, etc., I'm sure you guys will figure it out.
Yeah.
And then also point you to all these great resources that we used. And of course, if you're doing our ResNet CEUs, let us know. We'll get you hooked up with the LMS system. So you can go ahead, Mike. Let me kind of pick off some of these questions here.
I think that's our last slide, I believe. So I'll speak extemporaneously here and just say, I cannot, of all the projects I've done on our house, and I've done this on other houses too, there is a very big retrofit project. I do not want to undersell the effort. It is a major effort.
Mm-hmm.
But it is also one that has the most directly impactful comfort benefit, at least in our house. And our humidity levels inside our home, because of other air sealing too, but particularly when we closed up the crawl space and it became a conditioned space down there effectively, we stopped getting cold, dry air, which would over dry our house in the winter. And we used to have to use a room humidifier as a Band-Aid. And
Mm-hmm.
we know we never have to do that again. So I really want to say a lot of good things about this. Are you
Uh,
ready?
yeah, I think so. Well, White, you said that it took a lot of effort. I think you're dancing around it. How much money are we talking about here? That's what the people want to know.
Oh, well, how much you got. I think if you're a DIY person, the materials aren't too bad. You can do a lot of you can put in a French drain. You probably have to pay to upgrade a furnace if that's
Mhm.
an issue for you. But the materials are not so bad. So it's a matter of what are you willing to do. I think I was going to say I also decided uh, I was taking too long on getting this done. And
Mhm.
so I have a friend that's got a company locally, and I hired them to help me do some of the work. And it was mainly to kick it in gear and get it done. And I was able to take, at the time, there was a little bit of a rebate I was able to get back from our utility. Uh, Unfortunately, the modeled energy savings didn't really qualify me for the big bucks, but I
Mhm.
still was able to get like $700 back, which was pretty decent. Um, and I paid to do a little bit of mold remediation in there as well, just because I thought, I want to start off strong. But it it was worth it. I'm just going to say it was worth it. So I think, and there are companies that do this. Very often they don't do the whole package. So they'll
Right.
do parts of it. So you can talk to them and find out what they're going to charge. But if you don't mind getting your hands dirty and crawling around a little bit, you can do a lot of this yourself. It's just
Mhm.
I found it was very hard to self motivate to get into the crawl space.
Yeah, I can imagine. And that reminded me, we actually Mike did kind of a journal on
Oh
how all
boy.
this went down. It has a lot more information if you're interested. And it does talk a little bit more about the pricing. So that's actually included in the handout section here. It's called Barsic Crawlspace Story 2019. So
Well, who wouldn't want to subscribe to that? Yeah.
sure,
So
yeah, definitely.
you can get your nerd on for sure.
So one thing that came up is that maybe the IRC has amended that dehumidification requirement. We've got some detectives that are sending you some information. Um,
I
but
hope so.
but while we're talking about that, if 70 pints per day is too much, then what would you recommend? I know that you said that yours was 45 pints per 1,500 square feet, so I'm guessing somewhere in there.
Well, I'm going to say, guess what? Physics wins on this one. I'm trying to find that slide. Physics wins on this because I mean, let's face it, if you handle your exterior bulk moisture and you have good plastic down and you don't have vents, where's the water coming from? I
Right.
mean, ultimately, that's the three main areas that water gets into foundations is because of bad drainage. So there's bad drainage, and
Mm-hmm.
because of vapor retarder, or not having good vapor retarder, it's ground moisture, and then because we're dumb enough to put vents in because the code told us to.
Mm-hmm.
So I think I'm trying to find that thing about crawl space dehumidifiers. I'm going
Uh,
slow here. But
yeah.
my take is I think the 70 pints per day per 1,000 square feet. I would say this. I think you could use a 70 pint per day in any decent size crawl space. I think that would
Mm-hmm.
be a good one. Here we go. Because and what's good about the 70 pint per day threshold is that dehumidifiers just sort of go to a whole nother level of efficiency when you get that low
Mm-hmm.
to that
Right.
point. So any 70 pint per day is going to be more efficient than one of the ones on the left over here. So I think that's probably true.
Yeah,
But
and actually, while we're on this slide, someone had said that some manufacturers might recommend you not put that type of home unit in a crawl space.
yep.
Um, just yeah, so follow their recommendations, and my recommendation would generally be to just not do that if you can avoid it as well. These
Well, it's you're right, and some of them are not made to drain away, and some of them will lose their settings if the power goes out. So
oh yeah.
that was another one. The one I had was actually performed decently well, even down to cooler temperatures, and so I was pretty happy with it. It just except for the bursting into flames part, that was the downside of it.
All right, a couple of questions here. Maybe we can tackle these. If your crawl space has a concrete slab, like a rat slab or otherwise, should
Nice.
you should you post a should you put a vapor barrier down on top of that? And
I
it's
don't
been
think you need
established that
to.
there's not one underneath the slab.
Oh, oh, okay. I was going to say, if there's plastic under the slab, then no. I think that's the biggest benefit. A rat slab is really nice because it the biggest argument is it protects the plastic. So if you have plastic under it, great. If you
Mhm.
don't, I think I probably would
Yeah,
because
you're still gonna
you're
have.
going to get, yeah.
You,
I would say it's better than having to do it over dirt. So it's probably not as painful as a job to do, wear knee
yeah.
pads, but I would do it. Yeah.
And then the details on adding the foam board insulation. And actually, I'm going to try to find this one, so you might lose control here in just a second.
No, go for it. That's great.
Um,
So adding foam board, um, generally I'm an advocate of some sort of adhesive. There it is, 42. Adhesive and sorry, 41. And mechanical fastener.
mhm,
And there's, I don't think you need that many. If you use, for example, like construction adhesive, like I did, this is what I think we did on mine is foil faced polyiso, use construction adhesive, essentially glue it to the foundation wall, and then use a few mechanical fasteners, not that
mhm,
many.
yeah,
And the glue, and they're holding it till the glue dries. I think that works well. You do want to make sure, if you're not aware of it, that generic liquid nail construction adhesive can chew up XPS foam. So you need to, if
mhm,
you're going to glue that, you got to make sure your adhesive is the right one. Let's
right.
never forget my favorite material that's useful for every purpose on the planet, which of course is duct mastic.
Da
So
da
I've
da.
used duct mastic. I've
You
used
went.
duct, and you see pictures of it where we managed to mastic the plastic to the foundation piers and things like that. So
Yeah, I
uh,
think you went
I've seen
the
people.
whole presentation without saying mastic until the very end there.
I'm losing my touch there. I know some folks that had a spray-on adhesive, a 3M spray-on adhesive that they liked. They spray it
Yeah,
on the wall and spray it on the plastic, let it get a little tacky, I think, and then it's almost like rubber cement, and it sticks pretty well.
yeah. And
We've
in this case
used
here, for the vapor barrier, are you going to go on the outside of the foam board, or are you going to tuck it in between the wall and
the
the?
vapor barrier. Yeah, it's not. You can't see it very well. The vapor barrier is applied first to the
Right.
foundation wall, so that's done first, and you got to go up at least 6 inches, and a lot of people
Mhm.
go up, to near the top. and because of wicking. And so you do that first, and then you put the foam board over that. I've seen people try to get a little too fancy with batten strips, put the plastic, then put batten strips, and then put the foam board. But it's like now your foam board is not in contact with the wall. So you got to think about, you want your insulation to be touching an air barrier. And I've seen people kind of overthink themselves, and I won't go into any more detail on that. Any other questions on foam board?
Not on foam board, but while we're here, I think there were definitely some questions about spray foam. Are there any considerations you need to take if you're just going to spray that directly on an old brick foundation or old block foundation?
Yeah, so I would recommend you take a 2x4 and you nail it up at the top horizontally right below the floor joist. So that'll essentially be a stop for your spray. You're not going to spray that part. And then I would probably go with closed cell foam on this. I think it's just, got kind of its own, what do I want to say? It's more durable. It's got a lower vapor retarder output. I think it's below 1 permeability. That's the word I was looking for. So I think I would go closed cell. You might, I would probably run the plastic to the wall first and then spray down to it. And then when you're done, I would pull that 2x4 at the top so you have a view strip. You could still put a plug of rigid foam board in that spot. And then you have to decide about the band area. Again, energy performance wise, spray foam is awesome in the band area. Inspection for pesticide, not so good. So that's a concern. Thank you that you see in that picture. Joey, anything you want to add on that?
Well, yeah, I think maybe we didn't give band joist there enough due in this presentation. Maybe we'll do a whole hour on band joist, but the pest control might not even like that top left one because it looks like that one part spray foam has like kind of cemented that foam board in. So what I like to do is air seal the band joist itself, and then you can just put that foam board in there, and it just kind of friction
Yes.
fits in there. You really
Yep.
don't need to put anything on the outside. If you wanted to tack it in, you could, but
Yeah.
and in that case, the bat, if properly done, properly cut, is fine. And then that bagged insulation is really nice because you're not getting any exposed fiber glass that can give you any particle or anything like that. So
Right.
that's nice there. But yeah, you have to air seal behind there because it's going to be a major air leakage path.
And a guy like me is going to go, can I take some recycled, can I take some recycled plastic bags and just fill them up with insulation and put, anyway, don't listen to me. But I think that I definitely want to give the pest control people the access they need to do their jobs. And I agree with you.
Okay, let's see here. I think we're getting there. Just maybe some more technical questions than we can really answer in this format because you can't really respond. So I think
Well, also email. Let's push for email. You can, or like you said, send us the questions via this, or send us an email and let's follow up. I
yeah.
think all of that is good information, and there's our email. So, and then I also want to say again, thank you to those who are helping to support Southface. We want to stay in business and still be around and keep being able to do these. So thank you so much, and hopefully you'll keep. I was thinking about this, Joey. We're not trying to be Instagram influencers. We're trying to be Crawlspace influencers. Is that our new role?
Yeah, we need a
Title?
hashtag.
So, yeah, exactly. So anyway, it sounds like we're wrapping. So I will say thank you so much to everybody, and love to have follow-up conversations with you. Email's a great way to get a hold of me. But again, thanks so much for your participation.
Yep. Thank you, everyone. Hope to see you next week.
All right.